1 says,
Actually, no.
express in terms of I. This is an imaginary number.
It's going to take me longer to write this problem down than to write the answer. Because there's really not much to switch over. There's not much work here.
This is square root of negative 100. Someone want to tell us the answer? 10i. 100
is a perfect square, so the square root of 100, we know that that's 10, but since it's negative, we stick on that imaginary unit I for 10i. Okay. So 10i.
I. Okay.
That'll be easier to do the reviews.
Oh, number 20. Number 2.
Number 2.
So the square root of negative 20.
In case y'all haven't realized it, the test problems are like the review problems. They have the same instructions, and one student was texted me that, or emailed, but she was getting the right answers but putting them in a different format, and she didn't know which format to put them in. I looked through and I couldn't find anything. Her different format was just so completely wrong. But I was looking through to see, was she putting answers in some different format? And no,
correct different format.
And she wasn't. Okay. She had wrong answers, but it wasn't a different format. The answer is supposed to be 5, and she wrote 82. What format?
Okay. Is 20 a perfect square? No. What's the largest perfect square that divides evenly into 20? 4. So here's how I'm thinking of that, okay? I'm thinking of negative 20. I'm thinking of that as negative 4 times 5. So we have the square root of negative 4 times the square root of 5. How do we denote the square root of negative 4?
5 plus 2i. 2i.
Okay, the square root of 4 is 2. Since it's negative, we stick on an I. What do we do with this thing here? Just bring it on over. So 2i square roots of 5. Is this familiar?
2i square root of 5.
Use the quadratic formula to solve the equation. Okay, this is number 3. 2x squared minus 3x equals 1.
How many times did y'all use the quadratic formula this semester?
Too many.
A lot of times.
And now, there's only one correct first step.
Bring that one over.
Okay, whether you're factoring or using the quadratic formula, you need the equation set equal to 0. Also, you want that leading coefficient to be positive, so the sensible thing to do is to bring that 1 over. So we have 2x squared minus 3x minus 1 equals 0. Remember, when the 1 goes over, it becomes negative, or the sign changes. And now we can identify A, B, and C. A is, B is, okay, take that sign, good. C is negative 1, and
Negative B
plus minus the square root of b squared minus 4ac all over 2a negative b. The opposite, b is a negative 3. The opposite of negative 3, what am I going to have here?
Negative.
Negative is going to become a positive 3. B squared, I can do that in my head. Negative 3 times negative 3 is a positive 9. Minus 4 times A times C. A is 2 and C is? So, what about the denominator? That's easy. I can do that in my head. 2 times 2 gives me a denominator of 4. So we have a 3. Hey, what are we going to have? What have we got under this radical? Negative 4 times 2 is a negative 8 times a negative 1. That becomes. So we have here's what we have. Here's what I'm thinking. That's 9 plus 8.
17.
So we have a 17 under the square root.
So it's 3 plus minus square root of 17.
All over 4. I agree. Notice this number underneath there, 17 is not a perfect square. As a matter of fact, it's a prime number. You can't reduce the square root of 17. And now if it were negative, we'd have to use it, write it with an I and split up. But since there's no I, is there anything we can factor and cancel? No, here it is. 3 plus or minus the square root of 17 is on top.
Fraction Q.
3
plus or minus the square root of 17. And on the bottom, 4. Any questions? What's on number 4?
Oh, solve. Don't forget to check. There. It's sort of.
When we have a fraction, you don't want what number where?
0.
0 in the bottom. That's what it means by don't forget to check.
Uh-oh. Look what I did.
What did you do?
I wrote an X instead of a Z.
Oh, no.
well.
And you also put a plus? Oh, no. No?
3X, 7 over, it says Z, but I'd already written the X here, so I used an X there also. I'll be careful about that. We don't want denominators of 0. So look at this denominator. What number would give us a denominator of 0 here?
Wait, I'm not showing that.
4 times what is 0? 0. So we can't let X be 0. If we work through here and we get a 0, we're going to have to cross it out. So we don't want X to be 0. I'm just thinking to myself. So we don't want X to be 0. There's another number that's unacceptable. What's the other number that would be unacceptable? When would this denominator be 0? 3x minus 2. We don't want it to be 0. So that says 3x can't equal. Moving the negative 2 over, that becomes a positive 2. And then, what do I do to get rid of the 3? Divide by 3. So here are the two numbers. I remember weeks ago when we were solving, when we first started this stuff, the first few problems they were asking you, what numbers cannot possibly be solutions? That's what we just did here. We asked ourselves, when are the denominators 0? Those numbers cannot be solutions. Suppose I work through this and I'll wind up with x equals 2/3. Is that okay?
No.
No. Suppose I wind up with x equals 0. Is that okay?
No.
Suppose I work through this and I find that x equals 15. Is that okay? Yes. The only numbers that we can't allow are 0 and 2/3. Now, I remember solving an equation like this when we were looking at this stuff the first time, and I said it's a proportion. One fraction equals another fraction. Rather than multiplying through by the least common denominator, we had another way of solving this when we were looking at a proportion. Cross multiply, I agree. 7 times 4x, that's 28x. Oh, I'm still using x's.
Huh?
You're using a z, okay.
Oh, fix what? Change the x's to z's?
No, wait.
I'll do it. There.
Oh,
It's bothering y'all.
Yes, it's bothering me.
Okay, there are the z's then.
Okay.
Oh,
Sorry.
And here? What are we going to have to do there? So you took the 5 times, distribute, that's correct. 5 times 3z minus 2 gives us a 15z minus 10, I agree. That 28z minus 15z gives me, I think it's 13. 28 minus 15 gives me 13z equals negative 10. So what do I do now? Divide by 13 to give us z equals negative 10 over 13. Is that answer okay? Yes, the only numbers that would have been unacceptable are positive 2/3 and positive 0. Negative 10 over 13.
z equals negative 10 over 13. Any questions on that?
Keep in mind, all those smudges are z's.
Yeah.
Number 5. Uh-oh, it's an inequality.
We had a method, a little recipe that we used to solve things that have less thans or greater thans. Do you remember the name of it?
Starts with a C.
First word is cut.
Cut point or
Yeah, cut
okay.
points. When you see anything with less than, greater than in it, it says solve it. Then you use the cut point method.
Okay, so let's switch.
Okay, you put it down.
Okay, so the first thing we do, we see that inequality that says we're going to be using cut points. We had 2 types of cut points, solution cut points and denominator cut points.
There's no denominators here.
So we're not going to have any denominator cut points, but to find the solution cut points, we set the thing equal. And I think we can solve by factoring. X squared is x times x. We know something very nice about the signs. What are they? What is it? If the last sign's a plus, you have 2 of the first signs. So minus and minus. 3 and a 9, I was going to write down 1 times 27. What else? 3 times 9. Which pair? This is a simple trinomial, so choose the pair that adds up to give you 12. So I agree with 3 times 9.
Okay, is yours not working now? Because I've turned mine on.
No, I don't think mine is working.
Let me turn mine on. I was just testing it.
Okay. And that gives us 2 cut points. What are those 2 solution cut points? I agree with positive 3 and positive 9. And those are my solution cut points.
Right. For solution cut points,
You look at the original inequality. These numbers make the left side equal the right side. Is equality acceptable here? Do we have that little horizontal equality bar? No, so these are going to be open circles. Oh, that's bad. That looks 30 and 90. Forget that. There. Open circles. So we have 3 and 9 open circles. Remember, we had a method of looking to decide if we needed to test every interval, or when we look here, we didn't get repeated factors. We have different stuff inside the parentheses, so I'm 100% certain it's going to alternate. It's either going to be
test 0.
Okay, it's either going to be false, or true, false, true. So we only have to test one interval. 0 is my favorite number to test, as long as it's not a solution cut. As long as it's not a cut point, and it isn't. Which interval contains 0? Interval 1, 2, or 3? There's the first one. 0 isn't between 3 and 9.
3, 4, 5, 6, 7, 8, 9. Is it 0 over here?
Oh, okay. Okay.
Because I always think that side is the negative.
It seems like I remember the ones that we did. It seemed like we never had this thing where all the cut points were positive. We'd have a negative and a positive, and so 0 would be right there in the middle. But here, 0 is in the first interval. 0 is to the left of 3. So testing 0, we get 0 squared minus 12 times 0 is 0, plus 27 is greater than 0. True or false? True. So we shade. That's negative infinity way out there. What do we do between 3 and 9? If we had tested 4, 5, 6, 7, or 8, we'd cross it out. If we tested 10 or 50 million, true or false? Okay, so negative infinity, comma 3, union 9 to infinity, but I think we need something else. Okay, there's no closed circles, so all the symbols of grouping are parentheses.
Stop typing it in. Parentheses, negative infinity, comma 3, parentheses, union, parentheses,
9, comma infinity.
Comma infinity, close parentheses, and check. How do we know to do this cut point stuff? Because there's a less than or greater than symbol in it. Okay?
That's how we solved inequalities.
Let's see. Oh, we have time to do this one. Is there a less than or greater than symbol here? Yes. So what are we going to do?
Oops, this is at number 16.
Cut point again.
What number is this?
Number 6.
I keep writing 16. My goodness. So we have x minus 15 all over x minus 16 is greater than 3. I see that we have a fraction, so I know we're going to have denominator cut points, but we'll go through the process. The first thing we'll do is find the solution cut points. Set the left side equal to the right side. I don't know why I kept, oh, I know, I saw 16, that's why I kept trying to write problem number 16. I guess that's what was happening to me. What are we going to do to solve this equation for x? I can't hear you. So you're going to think of that as 3 over 1? Okay, that sounds sensible. 3 over, is it okay if I write it like that, 3 over 1? Okay, so we go x minus 15 times 1 is x minus 15 equals 3 times x minus 16 gives me 3x minus 48. I agree. 3 times, you're distributing the 3. 3 times x is 3x. 3 times negative 16 is a minus 48. I think I'd get the x's over on this side. Try to decrease the negatives. So minus x from both sides.
Plus 15?
I wouldn't plus the...
No. Plus 15.
And move the 48 over by plus 48, by adding 48. So the x's there are gone. Negative 15 plus 48 is 33 equals 3x minus 1x is 2x. I agree. And then divide by 2 to give us, for my solution cut point.
Let's decide right now between open and closed circle.
Open and close. Okay, you look back up here, there's no equality. For solution cut points, you always look at the inequality. That's it. There's no equality, so it's going to be an open circle. Not x minus 15. It's the denominator. Denominator cut point always open.
I knew that was a rule.
Okay, good.
Can't have a 0 in the bottom, so which one means to exclude? Open circle.
Okay, just like over here we were saying, you can't have a denominator of 0. So that same logic applies when you're finding those denominator cut points. X minus 16 can't be 0. So x can't equal 16.
Oh, I thought you
It said 15.
Oh,
I misunderstood
heard
you.
15.
Okay, so now, okay,
But-
I was right.
We both heard 15 when you said 16. Okay. Ooh, be careful.
Which number is smaller? Which one goes first? 33 halves or 16? 16 is smaller. That goes first. It's an open circle. 33 halves. If you wrote that as a mixed number, what would you get? Isn't that 16 and a half? 33 divided by 2 is 16, with the remainder 1. So this thing is just a little bit bigger. But we don't have to go through and check every interval. Look back through this messy work here. I don't see in no time do we have to factor. We didn't have any x squares. It's those even exponents that mess up so much stuff, because they take negative stuff, you square it and it becomes positive. But that we don't have any even exponents here, so I'm 100% confident it's going to alternate either true, false, true, or false, true, false. How do we decide which one? Test 0. Which interval contains 0? Interval 1, 2, 3. Okay. Okay. Yes. We can say, I know how to find 0 on a real number line. So testing 0. 0 minus 15 is negative 15 all over. 0 minus 16 is negative 16. Is that bigger than 3? Negative divided by negative is positive, so we have 15 sixteenths is bigger than 3. True or false?
16, 33, 2. No, it's false.
I think that's false. 15/16, that's smaller than 1. 1 isn't bigger than 3. That's false. Which means if we had tested something like 16.1, if you think of that as 16.5, then 16.1 or 16.2, true or false? True. And here?
5 minutes ago.
So,
Said the answer. So say it again.
When you say 16, 33 over 2,
good. That's not Caitlin, that's Kristen.
Oh. Well, earlier you did say it.
Oh.
A long time ago she said parentheses 16 comma.
Oh, okay. Let's punch it in.
And will we be finished by 3:30?
Depends on how fast you type.
16 comma 33 over 2. Hey, just the other day a student was, emailed me in another class about
Seriously?
they punched their answer in like that and it counted it wrong.
On a test.
Uh-huh.
On a
I don't know
test.
how many times you said.
You just, and something like that, if it happens, let me know and I will give some partial credit for it, but don't be shocked because the problems on the test are the exact problems from the review.
Only different numbers.
Only different numbers, but you enter the answer the same way. There's no time you should ever be putting that parentheses in the bottom of the fraction.
It was an
Okay?
accident.
So we'll
Okay.
pick up with this question on Wednesday. Okay. That's what we're doing the rest of the semester.